horizontal asymptotes of rational functions. So in a previous video, we talked about vertical asymptotes and how to find them. In this video, we want to identify horizontal. Looks like I forgot to change it on my copy. We want to identify horizontal asymptotes of rational functions. So what do we know coming in that we want to remember? We want to know that a rational function is a quotient of polynomial functions. So the rational function f of x is equal to a polynomial function divided by a polynomial function. And of course, because it's a quotient, the denominator cannot be 0, which in this case means the function q of x cannot be 0. We know what a polynomial function is. It's a function of the form f of x equals coefficient times x to the n plus coefficient times x to the n minus 1, etc., all the way down to a constant. If our powers are in decreasing order, then this is the function's highest power, and it is therefore called the function's degree. We'll be looking at each of our functions' degree in this video. And we know what an asymptote is. It's a line that guides the graph of a function but is not a part of the graph of a function. Okay, so what's a horizontal asymptote? Well, as you might imagine, it's a horizontal line, and horizontal lines are always y equals a number. It's a horizontal line that guides the graph of a function but is not part of it. Okay, it basically tells you how is the function going to behave as you go to positive infinity and as you go to negative infinity. Okay, we're going to, as we keep going and going and going to positive infinity, does the function approach or cross over and reapproach a horizontal line or not? And as we go to negative infinity, what's happening? Unlike vertical asymptotes, horizontal asymptotes can be crossed, and there's an example of that right here. Also, unlike vertical asymptotes, a function can have at most one horizontal asymptote. We learned that we can have multiple vertical asymptotes, and we can have multiple holes. We can only have one horizontal asymptote. So what do they look like? Well, here's a horizontal asymptote at y equals b. As the function, as x goes to infinity, as x goes off to infinity, this function is approaching b. Okay? So as we come up and x is going this way to the right towards infinity, it's getting closer and closer to b. The line y equals b is guiding the function. In this case, the function probably is not crossing b, it's just getting closer and closer to it. Same, in this case, the function is approaching the horizontal asymptote from above. As x is going toward positive infinity, the function is getting closer and closer to y equals b, or close to the value b here. And again, another example where the horizontal asymptote probably is not being crossed. Here's an example where you can cross the horizontal asymptote. The function comes down from above, it crosses the horizontal asymptote, it changes from a decreasing to an increasing, and then it begins to get closer and closer to the horizontal asymptote as x goes to infinity. So some different ways, there are a few different ways you can see horizontal asymptotes. The key is that it can only have one. It can be crossed, but then it'll shape it as it gets toward infinity or negative infinity. It'll shape it for you. Okay, so give me a moment. Let's talk about, I have an extra piece of paper, it looks like, for some reason. I'm not so sure what's happening here. I guess I have an extra sheet of paper. Yeah, I don't know. Okay, horizontal asymptote. Okay, as we mentioned, They guide what happens at the far left and the far right of the graph. In other words, when the values of x are really large, we're going toward infinity, or really small, we're going toward negative infinity. Okay, when you're going toward infinity and negative infinity, your polynomial's leading term, okay, in both the numerator and the denominator are driving what happens to the graph. The rest of the function has no meaning when you go toward infinity or negative infinity. So when locating horizontal asymptotes, we want to be looking at each numerator's and each denominator's leading term and degree. That's what we're going to focus on for horizontal asymptotes. How do we find them? Well, we look at the degree of the numerator and the degree of the denominator. Again, assuming they're written in standard form, so that that's the leading term and the degree of the function. If the degree of the numerator is less than the degree of the denominator, then y equals 0, in other words, the x-axis, is the horizontal asymptote. If the degree of the numerator is the same as the degree of the denominator, the horizontal asymptote's equation is y equals leading coefficient of numerator divided by leading coefficient of denominator. That's your horizontal asymptote. If your degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Things go off to infinity. We're going to see that here. Again, a fair amount of mathematical lingo, trying to keep track of it. Let's look at the three examples so you can see what's going on. Okay. Find the horizontal asymptote if there is one. As we said, there may not be one. And if there is one, there's only one, okay, of the graph of each rational function. So here we are. F of x is equal to 9x squared over 3x squared plus 1. Okay, as x goes to positive infinity or negative infinity, adding 1 to something has no meaning. So we focus right here, okay? Adding 1 to infinity means nothing. Okay, so we focus on the leading terms, okay? Notice our 2 degrees, they're both squares. So infinity squared divided by infinity squared is 1. So these become, once you get rid of this plus 1, because it has no meaning, this is a common factor. Okay, so we have the degree of the numerator equal to the degree of the denominator. Okay? When this is the case, okay, we know that we go up to, whoops, let me come back up to here. There we go. When this is the case, we simply use the leading coefficient because these become common factors. And so we're just looking at y equals 9 divided by 3. So y equals 9 divided by 3, or y equals 3. And this is the horizontal asymptote. Okay, let's take a look. Okay, let's go here to y equals. Clear out that one, put back in a fraction. I have 9x squared over 3x squared plus 1. Okay, let's go zoom standard. Okay, so here comes the function. And it looks like that. Okay, so you can see it's obviously, it's got something going on where it's stuck, not going too high here. If I go into y equals and I put in y equals 3 as equation 2, you'll see that line right there is hovering just above it. It is shaping it. This curve, this graph that comes in, it looks a bit like a bird's wings, or an airplane, not really an airplane, but a bird's wings. is being shaped by this horizontal line. In this case, it doesn't cross it. Okay, so that's what you see when you have the degree of numerator equals degree of denominator. Let's go down to this example here. Okay, g of x is equal to 9x divided by 3x squared plus 1. Again, as we go to infinity or negative infinity, adding 1 has no meaning. It doesn't matter. Okay, but the squared, okay, in this case, we have a 1, we have 1x up here, so this x to the first power is going to get really overtaken by the x squared term. Okay, so the degree of the numerator, 1, is not going to grow nearly as fast as this, and so something divided by a larger and larger denominator is 0. Okay, when your denominator gets larger and larger and larger, the fraction's value goes to 0. So here we have degree of numerator, which is 1, is less than the degree of the denominator, which is 2. D-E-N-O-M-I-N. Okay, which tells us, if we look back at our little cheat sheet up here, okay, degree of numerator is less than degree of denominator. We do have a horizontal asymptote. It's the x-axis, the equation of which is y equals 0. So this tells us y equals 0 is the, and we only have one horizontal asymptote, if there is one, is the horizontal asymptote. Okay, and again, you look at the leading things, okay, the leading terms, and we have a common factor of x, so this x can go out, and we're left with 9 divided by 3x. Well, as x goes to infinity, this is 9 divided by infinity. That goes to 0. That's why y equals 0 is the horizontal asymptote. Let's take a look. Okay, y equals, numerator is just, numerator is, let's delete that, 9x. Oh, okay, that's the same, that's the function. I'll graph this. Here's the function. It looks like, so this one crosses. Okay, I forgot about that. Whoops, I didn't mean to put my y equals 3 still in there. Let's take out that second one. We don't need that in there. Whoops, just clear that. Okay, so there's my graph. Notice the graph is coming, how is it being shaped? Okay, this is how it's being shaped. We're crossing y equals 0 at the origin, obviously. But as x goes to infinity, the graph is coming from above and is getting closer and closer to 0 from above, y equals 0. As x goes to negative infinity, the graph is getting closer and closer to the line y equals 0 from below. So here's the horizontal line shaping the ends of it, but not affecting the middle of it. Okay, last example. I think I'm still, let me get my, for some reason I'm not, let's make sure I can get it so it's focused. Come on, focus. There we go. Okay, sorry about that. Last example. Okay, h of x is equal to 9x cubed divided by 3x squared plus 1. Okay, again, we're only concerned about the leading terms as we go to infinity or negative infinity, adding 1, adding 2x, adding whatever to the ends of these things has no meaning as you go to infinity. So we're looking at these two, and we notice common factor. We have 2x's down here and 1x up here as we simplify that common, the leading terms. And so we have a numerator that's going to infinity, 9 times infinity, and we have a denominator of 3. Well, infinity divided by 3 is infinity. So here's an example where we're not going to have a horizontal asymptote. because we're not going to have a y equals infinity horizontal asymptote. Okay, so degree of numerator, in this case it's a 3, is greater than the degree of the denominator. Okay, and in that case we have no horizontal asymptote. Okay, let's take a look. Y equals, clear that one out. Excuse me, let's get my fraction back in there. Excuse me, 9x cubed divided by 3x squared plus 1. I'll graph that. I'm not even sure how this is going to come out. I should have, there we go. Coming in there, doing a little something there, but there's no horizontal line shaping that whatsoever. Okay, nothing that the graph as it goes to positive and negative infinity, the graph is not being shaped in any respect. So there you have it, how to find a horizontal asymptote if there is one. And what you want to be focusing on is these leading terms and their degrees. If the degrees are the same, then the coefficients dictate the equation of the asymptote. If if you have a degree of numerator which is smaller than the denominator, y equals 0 is your asymptote. If the degree of the numerator is larger than the degree of the denominator, you don't have a horizontal asymptote.